everyone, and thanks for joining us today. We're going to be talking about our new product, Global Mapper Pro. My name is Katrina Schweiker. I'm a product manager here at Blue Marble Geographics, and I'm joined today by Mackenzie Mills. Hi, Mackenzie.
Hi, Kat. I hope everyone here is doing well.
Yeah, I'm excited to, we got a lot of things to cover today, so I think we'll go ahead and start right in. So just a little bit of a reminder about the format today. So all of our attendees are in listen-only mode. If you do want to ask questions, you can use the questions panel. We are recording the session, and you'll get information about the recording afterwards. It usually goes up a day or two after we finish broadcasting. We also will, if we don't get a chance to answer any questions, we will be following up by email and also posting answers to those questions on our blog. So you can look those places as well if you are watching the recording. And of course, if you're watching the recording and you want to ask a question at that time, you can also email our technical support team, geohelp@bluemarblegeo.com. We'll also show that at the end of the presentation.
Just talk a little bit about the upcoming GeoTalks Express webinars that we have sort of towards the end of this year. Next week, we're going to do a webinar on managing data between Global Mapper and Global Mapper Mobile. So working with the Global Mapper desktop program, bringing in the mobile application for some maybe field data collection. At the beginning of November, we'll be doing a live user review. We're getting some folks from Blue Marble together with some longtime Global Mapper users that have been working in Pro the past few weeks, and we'll get some great opinions from them and just have a nice discussion about the new product and the functionality in the program. And on November 17th, we'll get back to sort of a workflow-based webinar here, and we'll conduct a suitability analysis for viticulture, so growing grapes for wine production and some different requirements for that, and how we can use Global Mapper to perform that analysis based on terrain and other characteristics. If you're interested in attending any of these upcoming webinars, visit our website, bluemarblegeo.com, to find out more information or register to attend.
Great, so we also have some training coming up. We still are doing a Global Mapper introductory class starting in November, and then we still have a class focusing specifically on Lidar processing. So that will also be in November. These are all digital sessions, remote sessions, so you can participate in them from anywhere in the world, and we do sort of alternate what time of the day we're doing it to make accommodations for different locations. So check out those schedules on our website, and of course in the future we'll be posting more things for 2022, what we will have coming up for trainings in the future. So today we're going to be talking about Global Mapper Pro. So Global Mapper Pro is kind of an exciting new addition to what Global Mapper has to offer. So this is an advanced license to the software that really extends what we had traditionally put into the Lidar module. So if you are a continuing user and you already have a Lidar module license with maintenance and support, you are eligible for Global Mapper Pro. So it's including all of the Lidar functionality, but we're also beginning to expand into a lot of other areas of advanced functionality. So our point clouds, we're starting to work with data other than just Lidar, and also we're starting to add advanced functionality in all sorts of other areas of the application. So the goal here is to really expand our professional tools into a variety of different areas. We're going to be talking about some of these exciting things today. So we've made some advancements to Lidar processing and point cloud processing with point cloud segmentation. We've added Python scripting to Global Mapper Pro. We'll look at the drone image processing with the Pixels Points tool, automatic break line extraction, a host of other things that we're going to cover today, and even more than we have time to cover in just an hour. So there's a lot of really powerful functionality included in Global Mapper Pro. So Kenzie, I think you can tell us a little bit about the agenda.
Yeah, exactly. So a little bit about some of the tools that are in Global Mapper Pro, some that have existed in the Lidar module, some that are new for Global Mapper Pro. We'll be going over a bunch of these tools today. As Kat said, we'll be working with the pixels to points tool, so processing some drone collected images into some 3D outputs, sort of some data creation to start with. Next, we'll move into some LiDAR classification tools. There's many different tools for LiDAR classification, LiDAR processing in Global Mapper Pro, but we'll look at a couple tools for classification and feature extraction. Next is a great new tool for LiDAR or point cloud segmentation and selecting segments, so helping to identify some more unique features in a point cloud, picking out some individual clusters of points and how you can select and work with those identified clusters individually. We'll be looking at some terrain painting. There's some updates to terrain painting in this new version of Global Mapper. Terrain painting is now part of Global Mapper Pro, and it's a great way to manually edit and manipulate a raster terrain surface. Going along that theme of terrain analysis, there's an automatic break line extraction tool now in Global Mapper Pro, so automatically pulling out vector features for changes in elevation or curvature in the terrain grid. We can also create some more features automatically with an automatic vectorization tool. This works with some raster data and works by creating some area features based on equal values within a raster data set, both images and terrain. And then finally, for some workflow optimization, there's a script editor tool in Global Mapper, so a user interface tool for editing Global Mapper and other scripts, and Python script integration in Global Mapper. This is big, new, and exciting for any Python developers out there who want to be able to use some functions from Global Mapper in existing or new Python scripts. And with that, we've got a long list of things to dive into for the rest of our hour here. So I'm going to hand the screen over to Kat to start talking about pixels to points.
Thanks, Mackenzie. So our drone processing tool for processing drone imagery is called the Pixels to Points tool. So this takes raw imagery typically collected from a drone, and it's able to create 3D reconstructions to locate those images and either stitch them together into an ortho image or create a mesh or a 3D model. So right now I've got an example of a study area here that was done. So these images were collected in this kind of back and forth sweeping pattern, which is very common. Let's use the info tool here to just look at one of these input images that was used. So this is actually quite a fisheye lens here, so we can account for that within our algorithm. But this is quite nice imagery that was collected, but of course it's not geospatially accurate in just its raw format. It just knows the single position of maybe the center of the image. But through the Pixels to Points tool, we're able to reconstruct that. So let's turn off the images here and we can take a look at this output. So this is the 3D model or mesh output from processing this data. We can also produce a point cloud, and the point cloud can be used with our classification tools, which Mackenzie's going to show in just a minute for working with point clouds. So the big thing that you might want to do there is to classify the ground, and then you can create a digital terrain model out of this data, or you can also create a digital surface model if you want to work with the terrain, or also using object detection. We could detect buildings and trees and maybe these poles inside of this particular data set. We've got a lot of pole structures throughout the terrain here, so we might be able to detect those as well. And then of course we also get the just the ortho image. So this should be accurate at each pixel location, showing the correct data at that location. So that's the drone processing tool. Lots of things that you can do in that interface to improve the positioning, correct for lots of different things, kind of optimize for your particular machine and produce those different outputs. So Mackenzie, I think you're going to show us a little bit about working with point cloud data.
Yes, I am. So, Pixels to Points is great for creating some point cloud and other data in Global Mapper. But once you have that point cloud data, whether it is a, LiDAR collected point cloud that you've loaded into the program or something that's photogrammetrically derived through the Pixels to Points tool, you can do some further analysis and classification with that point cloud. All within Global Mapper Pro here. So I have a point cloud layer loaded. This is just a tile of publicly available data, and I have it shown by elevation right now, so we can sort of see a little bit of our landscape here. We see some fairly regular rectangular buildings popping out from the terrain. We've got some interesting shaped buildings right in here. And the goal here is going to be to extract the building features to some vector areas that we can show in 2D and 3D. So to start, I'm just going to take a quick look at the metadata for this point cloud. Opening that up from the control center, we can see some general values, average for the entire point cloud we're looking at here, including the point density, the point spacing. And moving over to the statistics tab, we can take a look at any classification that is currently applied to this point cloud. Now we've got a few classes represented here. We've got ground, water, some noise classifications, and then railroads and bridges as well. And these were already applied when I received this point cloud data. We do have mostly unclassified points here though. And if I change my Lidar draw mode from the drop down up here, we can see that. So, I've filtered some of the noise classes out from this point cloud within Global Mapper. And we're right now looking at unclassified and ground points, ground with our brown symbology and unclassified in gray. And we can see that our building features aren't classified right now. Now, in order to pull these out as vector features, we want to classify these points. This can be done from the automated classification tools in Global Mapper Pro. We've got an option here for auto classification of non-ground points. This is going to be building and vegetation in our case. A couple different methods that can be used here, and you'll enter some parameters based on your point cloud to help guide Global Mapper to break the point cloud into some smaller clusters and then assign a classification based on the shape of those clusters and neighborhoods of points. Running that tool, we'll get a result where we have a little bit more of a colorful point cloud here by classification. So now we have our buildings represented in orange and vegetation in green, ground still in brown, and some unclassified points still mixed in there. Next, to extract features, we'll go back up to that automated analysis toolbar, and we have an extract vector features tool. Now this opens a larger dialog, and this is a LiDAR feature extraction tool where we can extract many different types of features here. And this is all based on a classified point cloud. So for this workflow, this data that we have now, I'm looking to extract buildings. To do that, I'll make sure we have that checked off. We want to extract the building footprints, so some areas representing where that building is. We'll simplify the buildings that were extracted just to, regularize or simplify the shapes. So we're getting maybe a little less artifacting in our footprints when they're created. We'll also extract roof planes and sidewalls, and this will make our buildings, pop up. We'll have some 3D features in here to look at our buildings in 3D as well. With our planes extraction, we have this new section down at the bottom of the LiDAR feature extraction settings here for ransack plane extraction settings. So this is a process that's going to run through and try to find the best fit plane to match our building points that are representing the building features in this point cloud. So our minimum distance to plane is how closely we want this plane to match the points that it's derived from. The minimum number of points that are needed in order for a plane to be created, the maximum iterations this tool will run through as it tries to find that best fit. And with those options for buildings, we can go ahead and extract those. I also just want to note that, Global Mapper has tools beyond just this building extraction we're doing here. On the other side of the dialog, we have options for extracting points representing trees and even coverage polygons for our trees. And then if we had higher resolution data with power line features or pole points classified within this data set, we could extract those as well. In order to get that classification, Global Mapper Pro does have an automatic power line and pole classification tool here as well. So a lot that can be done with just point cloud data in this program. With that extraction run, we'll get 3 layers since we chose to extract building footprints, walls, and planes. And from the top-down view, we've got sort of these planes overlapping and intersecting our footprints. Might look a little chaotic, but if we bring this data up in 3D, we'll be able to see our 3D point cloud, of course, but we can also see our sidewalls and, our building features that have been extracted. Now, these are vector features that can be exported to, any vector format from Global Map or worked with, edited. You can manipulate attributes related to these vector features as well. So you're opening a lot of doors as what you can do, starting with just this mostly unclassified point cloud.
We're also getting a question, Mackenzie, about creating a DTM, and I think another use for this might be to use those building footprints and include those when you create your terrain surface using the ground data. So you can create a very continuous surface where those building areas are totally flat, where that building base would be. So it can also be included in that type of data generation as well.
Absolutely. Those can be used to flatten the footprints of the building areas. And when you're creating an elevation grid from point cloud data, especially classified data like this, you can filter to maybe only use the ground classified points. So you're really getting a more accurate terrain model and ignoring any vegetation and other structures on top. To talk about a new tool that also appears in that automated classification toolbar, I'm going to pass it back to you, Kat, and you're going to talk a little bit about segmentation, sort of a new way of working with point cloud data in Global Mapper Pro and identifying some additional features.
Yeah, absolutely. So in addition to the kind of built-in named classifications that we can do, buildings and trees, ground, power lines and power poles, we have a new tool for segmentation of the point cloud. And this is really exciting. It really allows for custom classifications and just kind of dividing up your point cloud into what might be clusters of individual objects, depending on a number of settings that you're using. So let's take a look at this tool. So this lives in the advanced toolbar. It's called spectral partitioning or segmentation. So if you've used some of our newer methods that Mackenzie just showed, segmenting the point cloud to detect buildings and trees, this is kind of the lower level of that, where you have more flexibility over what things are being included in this custom segmentation of the point cloud. So with this particular data, I have, this is higher quality publicly available data. So it's about 0.2 meters between points here. So pretty detailed. You can see I've got some buildings and trees. I've got a big highway here. There's also a lot of residential area here. Let's zoom in a little bit here so we can see that. We've got a lot of buildings and trees. And as we look at some of these different attributes of the point cloud, you'll see that there's actually some ways where I can really get some detailed classification here. So in particular, I want to take a look at the intensity here. So if we look at the intensity, you can see, especially in this kind of overview image, the vegetated areas, even though they're probably all part of the ground, those are quite bright white because they are heavily vegetated. Probably grass is really reflecting that LiDAR signal. And then the pavement areas, the street here is quite dark. So we can use intensity as a way to kind of segment this data along with some of the other attributes and kind of add some additional information here. So I'm going to use a segmentation tool here to do this, and we're going to take a look at a few of these different attributes here. So we can choose attributes on the left side of our dialog here, what we want to include in our segmentation. So the position, there's no checkbox next to that because you pretty much always want to include the XY position as a factor in whether things are part of the same segment or not. The normal, this has to do with the orientation of the point. So this is actually perpendicular to the surface. So if you were to grid the point cloud data and then think about at a particular location, what direction would a perpendicular arrow be pointing? So for very flat ground areas, that's going to be pointing straight up. If you're following kind of going around a tree or something like that, especially through dense vegetation, it might point in all sort of different directions and have normals that aren't such a smooth, continuously varying. So we can use those statistics to help divide our data as well. We're looking at intensity right now in this point cloud. So this is, with some point clouds, this is a really good way to identify different things within the point cloud. Because this is kind of like a black and white photo, this is really telling us a lot about properties of the surface. We can also use the return number. So for this particular data set, let's take a look here. This is traditional LiDAR, so it does have multiple returns. So if I was trying to differentiate maybe the vegetation from some other attributes, I might want to use that multiple return. That's typically the main thing that will give you multiple returns. And then curvature. So we're going to look at curvature in a minute with another tool that we'll show for breakline calculation. This curvature is actually looking at the rate of change of the normals. So basically things with low curvature are going to be very consistently facing the same direction. If you can think of points as having a direction, but if you were to make a surface and think about very flat area, things are kind of the top or the outside, those are all kind of consistently pointing the same way, versus when you're going around an object, those have very different normals. So that has some kind of rate of change as it curves around that particular object. So that's what curvature is looking at. So we can use these attributes here, and I'm actually going to change these settings just a little bit. And so my goal here is actually to try and extract the roads here from the rest of the ground. So I'm actually going to first filter to show just the ground data. So I've already gone ahead and done some basic classification here to identify some different areas. If we filter to just ground, you'll see that I have a lot of the buildings removed, but I still have a lot of vegetation, those grassy areas, and then the streets, as well as that big highway. So we're going to go ahead and run this classification. We're going to run it on just a slightly smaller area here, just for time. Select a segment here. So we have some settings here that I'll talk through just quickly. So the connectivity, this is how many, roughly equivalent to how many segments we're going to generate. So a larger value is going to give you more segments, a smaller value is going to give you less segments. This is kind of a threshold of how large our segments are. So if you have things that are very small clusters and you want to exclude those, you can increase this minimum number of points in segment. We're actually going to bring our standard deviation down quite low. When you are using intensity, you want to bring this number down probably even below 1. With most of the other attributes, this number would typically be 2.5, I think, is the default, or maybe even 3, because we are looking at standard deviation in a multi-dimensional system here, so not just a 2-dimensional. So it is common to have a standard deviation quite high at 2.5 or maybe 3 standard deviations. But because of this intensity value, because these intensity values are such a small range and have kind of extreme outliers, we actually want to bring this quite far down to really get at that middle range. And then our maximum curvature value. So we can also use the curvature here as kind of a threshold. So we're going to ignore some of the stuff with that higher, kind of rougher surface, basically, by only using a low curvature value here. So only the kind of smoothest varying areas are we going to keep, and we're going to get rid of the very bumpy areas and not include them in our segmentation. So let's go ahead and perform this segmentation. So this is going to run through, in this case, I did run it on a slightly smaller area, but this is going to run through and detect some of our points here. And yep, so let's take a look at some of our segments. And I think I've actually filtered out some of the data that I wanted here. Let's turn on our road classification here. Yeah, so I think I actually forgot that some of these were pre-selected here, but using those same settings, if I had these points included, we would have actually come up with segments detecting these particular objects. And then with our select LiDAR by segments, we can actually go and custom classify these segments. So I'm using this digitizer, this new digitizer option, select segments. And what this does is when I click on a particular segment, and I can do this in 2D or 3D. If I turn on the digitizer in 3D, I can use it here too. It's going to select the entire segment. So I could custom select, there's about 3 or 4 different segments here that have really been able to identify the road. So I can custom select those and then change their classification. So I right-clicked with the digitizer here, go into edit, it can actually give them that custom road classification here. So there's a lot of power here with segmenting that really lets you divide up your data. We'll look at one other tile here briefly that I've already done some processing on. This is the next area down. We zoom out here. This is actually interesting because, you know, in addition to the vegetation and trees, this actually has a golf course here. And so you can see that through some segmentation settings, we're actually able to identify what is pretty close to kind of individual, you know, grassy areas or maybe holes because they are divided by some pathways. So they did actually come out in separate segments here. So really powerful way to custom classify. Let's turn all the point types back on here so we can see this original data. And really, one of the best ways to use this is to kind of start with some basic classification and then kind of filter to maybe one of those and go in and add some more detail. So in the example that I gave you, you know, I had classified by ground, and then using some tweaking of the segmentation values there, I was able to actually differentiate that ground into some different subcategories, including roads. So we could do the same with these other ground areas if we wanted to detect, you know, some of these grassy areas as well. But you can see how they are now separated into kind of separate clusters of points that we can do custom classification on. So that is the custom segmentation tool. So this works with all sorts of point clouds. It does need to be in this 3D point cloud type, but you can load any data in a text file format into this 3D point cloud data type here that would be accessible to all of these tools that Mackenzie was showing, as well as this new segmentation tool. So Mackenzie, I think you're going to show us kind of working with the next version of this product where you might start with a terrain grid. We can also do some terrain editing.
Yes, I am going to be talking about some terrain editing and terrain painting. You see I have a you know, terrain grid up. This is actually the same data set that I was working with, and this is a digital terrain model derived from that classified point cloud. Just to know, we are seeing all the great questions that you're asking. We do have a lot of content to get through in this hour, but we will be, you know, responding to those live questions via email. Kat did a great job explaining that segmentation tool, but you know, it is a little more complex. So we've gotten a lot of questions about some specific situations and parameters. All the parameters for that tool and all the other tools in Global Mapper are well documented in the program knowledge base. You can access that from the help menu right in the program or online. So, you know, of course, if you need just a little bit of extra explanation with those, you know, reach out to us or check the available resources as well. But to get back into some terrain painting here with my terrain grid in this workspace, you can see that with this LiDAR-derived DTM model, we've got some holes in our terrain grid, maybe where a larger building was. The interpolation didn't quite fill in those gaps. We also have a large sort of slash through this data set here. Now this area is a river. This is the Charles River. And I have a area feature, a polygon representing that region. So to, you know, edit this terrain grid a little bit, maybe fill in the gap, this river, as well as some smaller holes here, I'm going to start by just selecting my area feature, and we'll see why in just a minute. And next I'll open the terrain painting tool. Now terrain painting opens a secondary dialog up here, a floating dialog where you can set the operation, the brush type, and you'll really be using your cursor for the most part as a brush to, you know, manually manipulate and edit the terrain based on the selected operation and the parameters entered here. Our first operation up at the top is fill gaps. I'm gonna choose an area trace mode for my brush here, and that's all we need to set for this one. It's just gonna use the surrounding values, surrounding my little gaps in the data here. I'll scribble an area around, and Global Mapper will interpolate over to fill in any holes in the data set there. Now I could do this for my larger river area, but I want to flatten this river area to a specific height, to a water level. So I'm going to choose the operation to set terrain height here. You can see a few more parameters have popped up. Now, since I have this area feature selected, I'm going to change my brush type to selected features. This is new in Global Mapper Pro here, being able to use a selected feature as the basis for some terrain painting. I don't need to set my brush size specifically since my area of terrain that will be edited is dictated by my selected feature here. But I will change the units for my brush size, and that will in turn change the units for the feathering that we're doing here. Now, feathering is how well our flattened or edited area, in this case, the selected area I'm working with here, will blend back into the existing terrain on the other side of this polygon boundary. I'm gonna blend by just about 2 meters, and then I'll set the height, so my water level where I wanna flatten this area. With those set up, I'll click to paint selected features, and Global Mapper is gonna go through, find the boundary of my area, and edit the terrain for this section to repair any gaps here. And there we go, Global Mapper is filled in this area. I have some more little gaps down towards the bottom of the grid right on the edge. Again, I can just fill the gaps there. And then there's a variety of other operations for maybe some more advanced terrain editing. You can raise the terrain height or lower the terrain height, just change an overall value. You can slope the terrain to create a ramp, along a line that you draw up or down, or slope the terrain across the line. So this would be sloping perpendicularly to the line in order to maybe cut a ditch or build a mound up, maybe alongside of a road in the terrain. You can also create holes in your data by setting an area to no data, and revert to the original heights from the loaded terrain grid and undo any painting that you have done. Also to note, in this little terrain painting dialog, while you're in this terrain edit session, really, you can undo and redo any painting or terrain editing. So if I hit undo a few times, we'll see that some holes in my data reappear. Redo, we'll just redo those, setting the terrain height and filling in gaps as needed. So we've just sort of scratched the surface on terrain painting, some manual terrain editing here, but it is a great tool to have a little more control over how you go about manipulating the terrain, and not just deriving it from, say, a point cloud or some 3D vector features.
Great, so it looks like there's quite a few questions about this tool as well. Again, we've covered this a little bit in the past, but there's a lot of great resources about this, and this is a really fun one to just play with if you want to either use your license or maybe get a trial license and try out this tool. It's very fun to interact with the data and kind of sandbox your way into a new terrain. So we're going to take a look now at a little bit on the other side of terrain analysis, kind of extracting some data out of terrain. So this is our new break line extraction tool. And what I have here is some terrain data. This is quite a varied landscape here. This is actually near the Bay Area in California. So I've got some quite steep mountains here, as well as a river, and there's actually some levee features in here as well. And you can see as well, there are some sort of road features going up the mountain here. So those are all things that we might want to create break lines from. So using this terrain data, we might want to detect where these kind of distinct edges or curves in the terrain are, where we want to make sure that those height values are enforced in any products that we produce. So this might be used for creating tins or for creating other versions of your terrain data, or just as its own product. Kind of a alternative to contours, just a different way of representing kind of the important features in your terrain. And just for context, let's take a look at our imagery. So of course, with Global Mapper Pro, just like with Global Mapper version 23, you can stream in imagery from online sources. And in this case, I'm looking at some imagery for this location just so you get some context. So we've got a river feature here. We've got some kind of shallow marshy areas, and then a lot of streets throughout the lower areas, and then obviously this mountain area. So let's take a look at doing some break line extraction. So we have quite a few options in this breakline tool, depending on what kind of features you're trying to extract as breaklines. Those different features that I mentioned, those do have some pretty different properties. So the first thing that we're going to look at is sort of the opposite of what Mackenzie was showing with terrain painting. I want to find the shoreline, basically, of this river. And so this very first option is very good for doing that. It's basically tracing a boundary around flat areas. And we can determine what that size is for, what that tolerance is for what slope is considered flat. If I were to draw a profile across this landscape here, actually, let's do that real quickly. So if I just draw a profile across the river here, I could use my measurement tool if I want to, and just kind of take a look here. There's not perfectly flat here. I have a little bit of a slope, so I'm going to give this about a 2-degree slope tolerance here. Let it have a little bit, not just 0 slope, but a little bit of change in slope here that would be considered still flat. And that's going to allow me to capture basically the shoreline here as a breakline. So let's go back to the breakline tool here. So I want to use this first option, and I have increased this a little bit from the default up to 2 degrees of tolerance. I don't have too many gaps in my data here, but there are a few areas, so I could increase this gap fill size a little bit if I wanted to. And then lastly, there are quite a lot of features in this terrain. So I'm going to choose, in this case, to focus on kind of the larger river feature here. So I know that this should create some pretty consistent, unbroken, longer break lines. So I'm going to increase this minimum length. There's some similar settings to what you might do with contour generation. We have options for smoothing out the final product here. We also have this new option, which you'll see a few other places, for doing a Gaussian blur. This is a smoothing, kind of that bell curve type smoothing of our data. So this usually produces a little bit nicer of a final product here. We're just smoothing out our data a little bit to create some nice lines. And again, we can try this on a smaller area if you wanted to test out some settings. So let's go ahead and run this on the landscape here, see what we get for break lines. I have ahead of time here changed the style for break lines. So this is a feature type, and you can customize the style if you want to. And the default, I think, is just a black line. I have made this a bit brighter just so we can see this on the different landscapes. So that option you can get to in configuration. There is a feature type for break lines that you can customize. So you can see I've gotten a pretty good boundary now of this river feature just by automatically extracting those break lines. And some of these other kind of low-lying areas where we've traced around those as well. So there's a few other breakline algorithms that I will show you quickly here. I think we're gonna probably, based on time, just jump to some final results here, but I will bring up the dialog quickly here and talk about the options. So we can draw regions around areas with similar slope. And then the bottom option, this is kind of your standard breakline classification tool. So this is probably the most common one, and this actually creates a curvature grid. So unlike the curvature we were talking about in Lidar, this is basically the rate of change of the slope across the landscape. And you can do that. There's a few different ways of calculating that, kind of across the slope or up and down the slope. And then you can also just use the slope grid directly and create some edges based on the slope directly. So the first one I'll show you is using the standard curvature grid. We can actually see what that curvature grid looks like. In the analysis menu, you can generate these curvature grids directly if you want to see them. This option is create curvature grid from terrain. And so that standard curvature grid, you'll see this is a black and white image, and this is showing me that kind of rate of change in the slope. So it's a little bit different than slope. We're actually seeing that rate of change, and you can see how it can pick up on that levee feature. That's that sort of black feature right here. You can see some differences, for example, around the base of this mountain. So these are all things that the different breakline settings might help us extract using that curvature grid. So I've run this with a few different settings to produce some different results. So with a very low, let's actually show this one first. So looking at only the longest lines here and quite a high tolerance, this has allowed me to pick up this levee feature here. So this is kind of an embankment or a levee around the top of the river. It's quite a drastic break in the terrain. Let's do a profile across this again, just so you can see this. So across this profile, I've been able to capture those break lines right making sure that I'm drawing on either side of that levee feature here. So we have break lines now capturing that data. And then bringing those edge detection much lower, we can also take a look at trying to extract these individual road features. So if we zoom in up in this area, so these are much slighter differences in the curvature. So by bringing down that thresholds and then also filtering again for the distance, I can get some of these more subtle kind of curb, edge of pavement or curbs throughout this terrain data. Again, this is fairly high resolution Lidar, so I do have the details in order to see that in my terrain data, and so the algorithm is able to find some of those edges there within these kind of subtle variations in the landscape. So that is automatic break line extraction. So lots of options there for different types of break lines that you might want to extract. And that's another great tool to take a look at and kind of play with some data to see what you can get. So Mackenzie, I think we're headed back to you to take a look at our next tool here, which is automatic vectorization.
Yeah, so another way to create some, vector features from raster data. This tool can work with Imagery or raster terrain data, a terrain grid like Kat was working with, and we'll be taking a look at both of those methods here within this workspace. So my first data layer that I have displayed is an image. We've got a lake feature fairly prominently in the center of this image, and I want to find a vector feature or create a vector feature in Global Mapper that is the boundary of this lake. To do that, we have this Vectorize raster tool. I can enable this from a digitizer toolbar up here. Choose the layer I want to operate on because I do have the option to operate on the raster image or the terrain grid. We'll start with the image, and we have our setup vectorize dialog. So what this tool does is finds and bounds pixels that have similar or matching values. So each pixel of a raster layer has a particular value. In the case of an image like this, it's an RGB value. And based on how closely pixels match each other, Global Mapper is going to create area features around those pixels. To select the color of pixel that I want to start matching in this image, it's going to be our lake color. I'll click to select a color, and I could choose a color from this general color picker or sample a color from the map here with the pick color from map button. I get the little eyedropper tool. I can go ahead and just grab a sample pixel from the image. Got that color there, click OK, and we now know that we're extracting this specific color. We want our lake. Next, we have a matching slider here. So we go from exact to fuzzy, and we have a percentage value. If you're noticing down the bottom of this dialog, as I sort of gently bring this slider bar back and forth, we can see some changes on this little image preview down here. So this controls how exactly the pixel values that will be included in the generated areas need to match my selected color up here. Moving all the way to exact, we're only going to extract pixels that exactly match the sampled color. Much more towards fuzzy, and we're getting a lot more, values from this image. Nearly all the values would be extracted and bounded in some, much bigger area features. I'm going to set this down, towards about 9% here. We've got our lake bounded. We've got a little bit of, some very small areas creeping in on the side of our image here, but we can filter those out with this bottom option to discard areas or get rid of areas that are smaller than a certain threshold. Set your area units here. I'll go with anything smaller than 2 acres we don't want to keep, because I'm really interested in this larger lake feature, fairly substantial, definitely bigger than this 2-acre threshold. Above that, we can choose to smooth the created areas. So the features that are being created with this tool in their raw value are derived from a raster data format. So they're going to have the hard, square edges of the pixels that are represented in this raster. Smoothing the generated features is just going to give them a rounded, more appealing, more organic shape here. Global Mapper will work to, retain that accuracy, but smooth out any of those harsh, maybe unneeded corners that are derived from the raster pixels. With that, I'll just run this for the data visible on screen. We don't need to run it for the larger image. And click OK. Pretty quickly, Global Mapper is going to find those equal value areas, combine any smaller areas, and we end up with a few features representing our lake, our water areas here. If I turn off the image quickly, we'll see that these features by default are colored with that selected, color that we sampled from the image. And zooming in, we don't have those harsh, square pixel edges. But this does fairly well match the edge of the lake that's described in our image. So we've just created this vector feature. We can assign attributes to it, export it, do whatever you would like, now that you have some created data in vector format. To move on to another example, I'm going to turn on a terrain grid here, a bit of a larger area. And right now we're viewing this by elevation, and we can extract or vectorize this raster terrain grid based on some elevation values that I have here, but we can also use slope values. And to determine whether you're going to be prompted for elevation or slope values, that's determined by the shader that you have applied to the elevation grid. So up here, I'm using an elevation shader. This is an Atlas shader. I can move to the default built-in slope shader. And we've got this nice gradient. We can see, where the flatter areas are in some lighter colors in this terrain grid. And then we've got steeper, higher slopes in our darker areas. I've also created a custom slope shader that I'm going to apply. And this breaks the slope of our, terrain grid here into some discrete classes with some brighter colors, just so we can more easily see what we're looking at in terms of slope values here. So I'm going to bring up that same Vectorize raster tool for this terrain layer. I can pull that from the digitizer menu once again, or it's also available from the layer menu up top here. Choose to vectorize raster with our terrain grid. And we have the same options here, but instead of selecting a specific color and setting a match distance, we're going to set an upper and lower limit for our slope values. So we're specifying our slope in degrees here. I'm going to look to extract our flatter areas. So I'm going to go from 0 degrees to 5 degrees. It's our lowest class here represented in our shader. And for this extraction, vectorization here, I'm only going to smooth the areas once, little less smoothing here, and I'll discard only areas smaller than 1/4 of an acre. So much smaller threshold, since we do have some, smaller areas of low slope sprinkled throughout this data set. Again, just go ahead and click OK there, and Global Mapper is going to vectorize this area. I'll zoom in a bit to the corner of our grid where we've got a mix of large and small flattened areas, toggling that vector layer on and off. We can see that those are indeed our lighter colored, 0 to 5 degree slope areas, and they're colored with the value from our shader here as well. So I could repeat this process with this terrain grid, maybe work with my next discrete class of slope values here, 5 degrees to 10 degrees, and vectorize those areas as well. But for right now, we've just got our flat areas vectorized here. So this is a great tool, for any raster layer that you have in Global Mapper. You can create vector features in a more automated way rather than having to, manually digitize around a lake or, somehow crop the terrain grid here by slope in order to extract some features. So really working to improve efficiency with the workflow and just, some more data creation here.
Yeah, that's awesome. I know we've gotten a lot of customers looking at doing this, and it used to be quite a few steps to kind of get at this analysis with terrain, but now in this kind of one tool, we have people looking for flat areas for farming, for helicopter landing zones, for kind of off-road navigation of vehicles. And obviously you could do, other than just flat areas, you might be looking for the steep slopes, a particular elevation range, but it's really a one-stop shop for both that height or slope filter, and then also those area categorizations as well if you want only the larger regions. So that's going to be a really powerful new tool. So we have just a little bit of time left here, and we're going to jump now to talking about some automation tools. So scripting options within Global Mapper Pro. So we have introduced in Global Mapper Pro a new script editing interface, and this makes it a lot easier to write Global Mapper scripts. So you'll see this from the file menu. You can either run script. We've had this tool option for a while for running Global Mapper scripts. We also have Open Script Editor. This lets you just open the editor and start writing a blank script if you want to start from scratch. So you'll see that this has a built-in editor now that includes things like syntax highlighting. So we're seeing in this Global Mapper script our commands and parameters kind of highlighted in different colors here. So with only a few minutes here, I won't have time to go into kind of the scripting options in a ton of detail here, but there are basically two options in Global Mapper Pro for automating your workflow. One is a Global Mapper script, which we're looking at right now, and I'm also going to talk about Python scripting as well. So the Global Mapper script is a great way to very quickly and efficiently automate what you might do through the user interface. So this example right here, we're loading, so setting the file, just defining it as a script, and then we're loading some data, and then we're generating contours. So this is a very fast language to learn. It's pretty straightforward. We just have a few lines of comments in there, but pretty straightforward. It's basically commands and parameters, and then you would enter the values for those parameters just like you would enter in the user interface. So it's very comparable to what you see in the interface. There are a few advanced options that are not included in the interface as well, but it's a great way to kind of automate your existing workflow. It can be run from the command line, so without interacting with the program at all and just outputting some resulting files that you might want to create. For example, I could export these contours to a shapefile in a folder and actually not have the application open at all. I can also make it somewhat interactive, ask the user that's running the script to pick the file that they want to load. For example, I can prompt for specific data or prompt for some inputs. But for the most part, it is just automating tools like you would see in the interface, but just without actually having to use the interface and interact, and just kind of running in the background. So let's go ahead and run this script. So this just quickly loaded some data and then generated those contours based on my values. A few other things I want to show you here before we talk about Python scripting. So the scripting interface, this is a file that's defined as a Global Mapper script. So you'll see this particular highlighting colors here. This tool also has code suggestion. So if I start typing, for example, there's a lot of generate commands. If I hit Control Spacebar, you're actually going to get some suggestions for possible commands here. So this is also a way to kind of speed up your scripting using this IntelliSense or suggestion here. So again, that was Control Spacebar to bring up that suggestion. So that's trying to auto-complete the command that I've started typing here. So maybe I remember, roughly the first letter of my command, but I don't want to have to go to the reference and look everything up. So this is just giving me all of those commands that are built into Global Mapper script. And you can see there's quite a few things that are automated here. And especially the generate commands seem to group a lot of those terrain analysis tools together. So I have the same script in my next tab here, but loaded as a Python file. So Python is a new interface that we've added to Global Mapper for a way to automate processes within Global Mapper and also to interact with other applications. So Python is an open source programming language that is used by a lot of third-party tools to do automation. So you can do the same type of analysis or automation of just Global Mapper that you might do with the Global Mapper script, and maybe you're just more familiar with Python and you'd like to use that. It is a little bit steeper of a learning curve if you're brand new to scripting. Global Mapper script is definitely a more comfortable way to start. But Python is incredibly powerful. So not only can it do the same type of analysis that we did with our global mapper script, it can also interact with the open application. So I actually have the same kind of type of script that I've created here in Python as what I did in global mapper. There's a little bit different of a setup here. Again, to go imported the two global mapper libraries, global mapper, and I've shortened that to just as GM. And then also we have a second library here that wraps a lot of our classes for our analysis tools. And so there are default values for a lot of the parameters. Without this GM library, a lot of those objects are just empty parameters and you need to set all those parameters. So by using this GM module within the global mapper library, you can also just kind of default some of those parameters like the contour interval. So I have actually commented out the file loading here, just to show you that I can actually work with my loaded terrain data within the application and kind of back and forth interact with my Python script. So this is one of the ways that Python is a little bit more powerful than global mapper scripting, is that we can actually kind of pause our script and let the user interact with the interface and then kind of continue adding additional tools here. I'm just going to do this very simple example here where we do the same type of analysis in Python, except this time I'm using my already loaded data in my workspace. This is because I have this generate contours command, and my first value is the data, and this is set to none. So this is just going to default to that already loaded data. So it's just going to use my already loaded digital elevation model. Let's go ahead and run this script. So that's going to do similar analysis here. You'll see I've done basically default settings here, except for setting a contour interval at 5, just to give you an idea of how you might interact with this in the Python library. So we've called this generate contours command, and then we've set up ahead of time our parameters in this object that contains those particular values. And the only one that I customized here was the contour interval. So I'm sure we will do a lot more on this in the future, but I just want to show you one more advanced example here. We're running out of time a little bit to go into too much detail, but part of what makes Python so powerful is also the ability to interact with third-party libraries. So in this particular case, I'm going to show you a quick example of working with some popular third-party libraries. So these are matplotlib used for graphing. NumPy is a popular library for statistical analysis. We're using a couple of those third-party libraries. So I did need to install those ahead of time using my Python installation. By the way, this works with Python 3.9 if you want to run it inside of the global mapper application. It can also be run as a standalone library. There are some instructions in the help for how to get that working. But when you install Global Mapper Pro, you have an option at the end of the installer to install a custom version of Python 3.9 if you don't already have it. But if you do have it, when you open the scripting window, it will find your current installation, kind of using the system information to locate your Python, your existing Python installation. So let's go ahead and run this script. So this is going to load some data into Global Mapper. I'm just going to pick an image here. And then it's going to use the same data in these third-party libraries to generate a histogram. And this is a type of histogram that we don't, I know this has been a popular request, but we don't generate this yet. So I've used a third-party library to do this multiple bands. So each of my bands of my image here has its own kind of set of RGB. We do this in separate graphs, but we haven't put it all together in one graph yet. So I can do that with this third-party library here. So this is actually a new matplotlib window that has opened up from that same script that I ran from my script dialog, but it has access to that third-party Python library as well to generate this data. And this script is actually still running as I have this dialog open, as I make changes. The script will still be running basically until I close this window. So yeah, Python is a very powerful new way to interact with not only Global Mapper, but also integrate Global Mapper with other applications and also make kind of custom tools within Global Mapper using the kind of the flexibility and the power of the Python programming library. So this is a very exciting addition to Global Mapper Pro. I'm sure we have lots of questions about this, but I think we're reaching the top of the hour. So I think we have a little bit of closing information here to give you if you have further questions.
Yep, so if you do have further questions, as we said, we'll answer, the questions asked live here. We'll follow up via email. But if you have more questions about, any of these new tools in Global Mapper Pro, general Global Mapper workflows, any questions related to licensing and whatnot, please reach out to us with the emails on screen. If you have questions about licensing, maybe upgrading to Global Mapper Pro from your existing license, reach out to our sales team, orders@bluemarblegeo.com. And then more technical questions, you can route to geohelp@bluemarblegeo.com. We've got some great application specialists waiting to answer your questions there. And either of those emails will make sure you get the appropriate response.
Thank you so much, Mackenzie.
Yeah, thank you so much, Kat. And I hope everyone has a great day and explores Global Mapper Pro a little further.